Today we're going to be talking about the normal distribution. So what is normal distribution? It is a distribution with symmetric curves or histograms. So in other words, it's going to form a bell curve, kind of like this picture here, kind of like you formed when you used the sticky notes and put them on the board yesterday. When they formed that bell shape, that was a normal distribution. So it was symmetric. So it's the same on the left side as it was on the right side. On the flip side of that, we have skewed distribution. So this is a curve or histogram that is not symmetric. Not symmetric. So something like this would be, if we were to graph it, this would be called negatively skewed. And then over here, this is positively skewed. So as you can see, if we were to fold this graph in half, it would not be symmetric. So the way I like to remember it, for negatively skewed, if you were to sled down a hill like this, you'd be going towards the negative x direction. If you were to sled down this hill, you'd be going towards the positive x direction. So it is positively skewed. So example 1 says, determine whether the data, all these values, appear to be positively skewed, negatively skewed, or normally distributed. So we want to see which of these three situations it's most like. Well, it's kind of hard to tell right now because it's just a bunch of values in no particular order. So what I'm going to do, I could graph these really in any way. I think the easiest way to go about it is to make a frequency table. And I'm going to make my frequency table going this way so I can kind of envision how the graph would be. So I'm going to make my frequency table. We're more used to making vertically, but this is the same idea. We just flipped it around. So our values are going to go here, and then our frequencies will go here. So it looks like, if I look at my data points, 31 is the lowest. So I'm going to start with 31. And they go all the way up to 37. So 31, 32. Okay, and then I'm going to count how many times I see each value. So 31, I see it one time. That's it. So the frequency is 1. 32, let's see, 1, 2 times. 33, just once. 34, got 1, 2, 3, 4 times. 35, 1, 2 times. 36, 1, 2, 3 times. And 37 is on there once. Okay, so I can kind of look at my frequencies. If I were to plot these frequencies, I would start at 1, I'd go up towards 2, down to 1, I'd peak right here in the middle, and then I would gradually work my way down. So, let's see, I've got 1 and 1, 2 and 3, they're pretty close, 1 and 2, and then the highest point is in the middle. So I'm thinking this is closest to normally distributed. This is not exactly symmetric, but it does peak in the middle, just like the bell curve does. If it were to peak towards the right, so if the highest frequency was over here, let's say, that would be negatively skewed if it kind of worked its way down and it peaked on the right side. If the peak was somewhere on the left side and then it worked its way down over here, that would be positively skewed. But since the peak is in the middle, it's approximately symmetric. So this wouldn't be exactly normally distributed, but that's what it's closest to. So I'll say normally distributed, and then if you want to add the little disclaimer, approximately. Okay, so flip to the other side. And I have this diagram of all the properties of this bell curve that, in this rule, kind of all the percentages that go in here, we're going to refer to as the empirical rule. So this is how we use normal distributions. So let's go through the properties of normal distribution. So here's our bell curve that we saw on the front side. Now, if something is exactly normally distributed, how we work this curve is the mean, our mean value is always in the middle. Okay, that always goes in the center. And then if we count by standard deviations, whatever the standard deviation is, so this is our mean, and then this would be 1 standard deviation away. This would be 2 standard deviations away. This would be 3 standard deviations away. So you count by whatever the standard deviation is. Now, between the mean and 1 standard deviation away, that's to the right side of the mean, that's 34% of your data. Same with the left side. So about 68% of the values are within 1 standard deviation of the mean. Here's your mean. There's 68%, 34 plus 34. And it says about 95% of the values are within 2 standard deviations. So if you count up 13.5 plus 34 plus 34 plus 13.5, you get 95%. And then about 99% are within 3 standard deviations. So these are the percentages we're going to be working with. You need to memorize these because that's how you're always going to start when you're working with a normal distribution problem. So let's look at an example here. It says, students in Ms. Vosa's class counted the number of Skittles in 100 small packs. They found that the number of Skittles per package was normally distributed with a mean of 23 Skittles per package and a standard deviation of 1 Skittle. So the mean is 23 Skittles. Actually, I'm going to add up here, since there's some room, just some general rules. So we'll say the mean goes in the middle of our bell curve. And then we're going to count by whatever the standard deviation is. Okay. And in our example, it says the standard deviation is 1 Skittle. So this is we're gonna count by ones on our graph. And again, you always want to start by drawing out your bell curve. So I'm going to draw that out. I'm going to write in my percentages. So just like on the diagram, I'm going to draw my bell curve, do these little arrows on the end. There's always a dotted line in the center. And your mean goes right here. So our mean was 23 Skittles. So that's going to be 23 on our graph. Then you go a little ways away, maybe about here-ish. And this is 1 standard deviation away. And like we said, we're counting by ones because our standard deviation is 1. So 1 away from 23 would be 24. 1 to the left would be 22. And let's label our percentages. So just like in the diagram, I'm going to put 34% here, 34% here. And then when I make my other lines, this is going to be 13.5%. And didn't make this quite long enough, but this is going to be 2%. And if I were to have kept this going, this is going to be 0.5%. So label your bell exactly like you see it in the diagram above. So this is 13.5, this is 2%, and then over here is 0.5%. So all I did was label my percentages. And I can continue counting by my standard deviation. So this is 23, 24, 25, 26, and then anything to the right of 26 is going to be the leftover 0.5%. So this is 21 and 20. Okay, and actually, what was the question asking? It says how many packages had between 22 and 24 Skittles. So between 22 and 24, is, well, between here and here, that's 34% and another 34%. So I'm looking at this area here, between 22 and 24. So that's 34% and another 34%. So let's write that down. We'll say between 22 and 24 is 34 plus 34. That's 68%. And, well, how many packs is that, though? I know the percentage. Well, the key is they tell me the total amount of packs I was working with, which was 100. So I know there's 100 packs total. So I want 68% of that number 100. 68% of the total 100. And whenever you're finding a percent, you take the total, multiply it by the decimal form of the percent. So I'm going to do 100 times 0.68, and that's going to give me 68 packages. And that's my answer. Okay. And then now I have a probability question. So it says, what's the probability that a package selected at random had more than 25 Skittles? So here's 25. More than 25 is anything over here. So I'm now looking at this area, kind of going on that way forever. So I've got the 2%, and then another 5% included. So this is going to be about 2 plus 0.5. That's about 2.5%. Well, that is 2.5%. And when we're talking about probability, it's okay to give your answer as a percentage. So that's all they're looking for there. They want the percentage for the probability. Okay, that's all I have for the notes. I am going to help you out with one homework problem. We'll just practice setting up a bell curve for number 5. So for these two sets of problems right here, you need to start by drawing and labeling your normal curve. So,
please excuse this interruption for a short announcement.
There's your announcement.
Anyone who is interested in wrestling, there will be a meeting in the University Center, rooms 1 and 3, starting at 3:30. After that, starting at 4 o'clock, anyone interested will meet in the weight room for conditioning. Thank you very much.
Okay, there's your announcement. Anyways, number 5 on your homework asks about what so it says, the time it takes a bicycle courier to deliver a parcel to his furthest customer is normally distributed. So it tells you it's normally distributed with a mean of 40 minutes and a standard deviation of 4 minutes. Okay, so we're looking for percents and whatnot. So I need to start by drawing my normal curve. So let's do that. I'm going to draw my bell. Like this. Okay, so in the middle, you always start with your mean in the middle. It tells you the mean is 40 minutes. So I'm going to put 40 in the middle. Now my standard deviation is 4 minutes. So that's actually what I want to count by now, is by 4s. So when I'm drawing my curve, you always want to start with your percents. So do your little dotted lines. Remember, 34% goes here, another 34% here, 13.5. Again, you want to memorize these percentages. And then 2% and 0.5% over here. That's always how you start. Okay, so 40 is our mean. That goes in the middle. Standard deviation is 4. So count by 4s. So right here, 40 plus 4, 44. 44 plus 4, that's 48. This is 52. This is 40 minus 4, 36. 32. 28. So notice I counted by 4s, not by 1s. And might as well do number 5. It says, about what percent of the courier's trips to this customer take between 36 and 44 minutes. So I'm looking at this area. Actually, this is the same as your lesson. So this is 34 plus another 34, so that's 68%. Because they're asking for the percent. Okay, you can try the rest of the homework problems on your own, or you can work with a partner.